Hi, everyone. Well, on Thursday, May 2nd, a fuel tanker caught on fire underneath an overpass in Norwalk, Connecticut, destroyed the bridge, and has resulted in just an utter traffic nightmare. This I-95 roadway carries approximately 145,000 vehicles a day. The roadway's been closed between two exits so that they can demolish this bridge. So I want to go over similar incidents that have occurred here lately with highway and overpass fires, and what, if anything, could be done to mitigate such circumstances, and also what's done typically to determine if demolition and replacement is necessary. The fire for this fuel tanker got started due to a collision between the tanker, a tractor trailer, and a car, from what has been reported. The tanker was carrying 8,500 gallons of gasoline, and they estimate that over 4,000 gallons burned underneath this overpass. This overpass is Fairfield Avenue over I-95. So as I mentioned, the roadway I-95 has been closed since Thursday, and there's a mad scramble right now to get in there and demolish this bridge so that they can reopen traffic on I-95. This is having huge impacts to commuters and on the local economy, far in excess of what it's going to cost to replace this bridge, no doubt. The other situation you have is people getting onto alternate routes to avoid the closed section of I-95, and they're traveling through areas that weren't designed for big vehicles. In fact, you see a truck here snagging overhead power lines. I mean, I'm shocked at how many overhead power lines there are, I guess, for electrical distribution. I mean, I've seen similar things in Thailand and Cambodia where it looks like a tree. You have a mast or a pole, and then hundreds, if not thousands, of electrical lines connecting into the tap. So it's pretty indicative of the infrastructure really not being suited for this situation. Now, last June, I-95 in Philadelphia had a bridge that was destroyed, an overpass, due to another tanker fire. And in this case, it was I-95 going over another roadway. So they had to quickly demo both sections, north and southbound, of I-95 overpasses in this location and rebuild it. And they did that in an amazingly short period of time. That involved some temporary construction that was later replaced by the permanent construction for the new overpasses. And of course, we have the I-10 fires that happened recently in downtown Los Angeles, where a lot of junk and construction materials that were allowed to be stored underneath the highway overpasses caught fire, they believed, due to being deliberately set by a homeless person. But that was a disaster, and they came in and put in false work to temporarily support the bridge and reopen traffic. Now, obviously, reinforced concrete or structural steel members for a bridge aren't designed to withstand high temperatures. And these gasoline fires produce temperatures well in excess of 1,800 degrees, which if you heat steel, for example, to 1,800 degrees, it's going to be red hot. And at that temperature, essentially that's forging temperature, 1,800 degrees. I've made knives before, and that's about what you heat it up to so you can start working the metal. So at that temperature, steel becomes very malleable. It loses a lot of its strength. And so you have the existing loads on these structural elements from the bridge, let alone any traffic on it. So let's say just the bridge itself, and then you lose strength, and then you have distress, distortion, and other damage. This has happened on numerous other projects. So one of the things you do post-fire as an engineer to determine what, if anything, needs to be done to repair or replace the bridge, you start out with a rigorous visual inspection. You can do things like impact echo testing. I actually have some of this equipment that I test on some of my bridge projects. And essentially, by assuming a compressive wave speed in the concrete, which is usually around 12 or 13,000 feet per second, this handheld device is battery powered and connected to a computer for data acquisition. And it has a little solenoid that when you trigger the instrument, it imparts a sharp impact to the concrete surface, and then the instrumentation records the two-way travel time. So if you have solid concrete of some known thickness and that signal matches that, then you know you've got a good solid section. But if you have delamination or separation or large cracks at some depth from the surface of the concrete, you'll get an early reflection. And if you survey in a grid fashion, you get a pretty good idea overall what the condition of the concrete is. Now, as I mentioned, officials in Connecticut have their hands full. They're committed to removing Fairfield Avenue over I-95 this weekend. I'm recording this video on Saturday, May 4th. And then obviously it'll take additional time to construct a replacement overpass, no doubt through some design build contracting mechanisms. Those tend to be the quickest way to get a bridge replaced these days. Now here's an example of steel girders for I-20 in Birmingham, Alabama. This was back in 2002. A tanker fire burned hot underneath this overpass, and the steel deformed several feet. You can see here it had to be demolished. The overpass had to be demolished and replaced. Now, what could be done to provide bridges with better protection? I don't think I've ever seen a bridge with any type of fireproofing. Now, in the past, when I worked for other companies, they would have a division that did inspection for spray applied fireproofing in commercial construction. So the idea is you just don't allow exposed steel in, say, a casino. I did a lot of casino work back then. And instead you spray this material that insulates the steel. And usually that's good for about 1 hour rating. So they're not designed to withstand tanker fires or anything like that. Just the combustion of interior finishes, floor coverings, furniture, that sort of thing, which can burn quite hot. But I don't think it's near the intensity that you would get from burning fuel from a tanker. And I've never heard of this for a bridge application, but it just makes me wonder. And sometimes you have just reinforced concrete overpasses. There's no steel girders. So it's maybe possible to increase the concrete cover thickness to provide greater protection to the reinforcing steel. It may be that the outer surface of the concrete is excessively cracked from the heat of the fire and has to be replaced. But that would be better than replacing the entire overpass. Another thing I wondered about is, could they face the lower portion of these overpasses, if they consist of reinforced concrete, with some type of, like a refractory type material or refractory brick? Again, there's a mix that you can make. It's similar to spray applied fireproofing. And I use this to pack the inside of my propane fired forge when I'm making knives. So these materials can withstand very high temperatures in excess of a few thousand degrees. So it seems to me it's probably unlikely that any bridges will be retrofitted with some degree of fireproofing, but I think it needs to be examined in busy urban corridors, and I-95 fits that description in the Northeast, whether it's Philadelphia, Connecticut, and other states. I mean, the traffic volumes are just astounding. In fact, that I-95 section in Philadelphia similarly had about 150,000 vehicle per day traffic count. So suddenly you can't pass that volume of traffic through a given section of roadway, and they have to divert to side streets. It's a complete disaster. I'll be curious to see if there's any standards developed or applied to new bridge construction. That seems to be the trend, that there has to be a number of these types of problems before eventually some measures are taken to address providing greater protection for new construction. So let me know what you think in the comments section. Is this a situation in terms of providing greater fire protection for bridges, something that should be done? If not on a widespread basis, certainly for key bridges or overpasses that may be vulnerable in areas with extremely high traffic volumes. I'd like to send a shout out to the channel members. I really appreciate your ongoing support. A number of you send me ideas and breaking news stories, which is fantastic. I appreciate it. Please keep it up. Also, I want to send a shout out to those of you who have provided super thanks. That's another way to support the channel. And I'd also, of course, like to thank those of you who have liked, subscribed, and left comments on these videos. There seems to have been no shortage of major bridge disasters happening in this country, and most of my work as an engineer in the last 20 plus years has involved bridges. So I'm keenly interested in these stories, and I think I can provide a unique perspective that's not presented in the mass media, certainly, and I don't think it's presented really elsewhere on YouTube. So thanks for all your support, and please stay tuned for future videos.